Hey boys and girls, today in math we are going to learn about 3D shapes. So 3D, the D stands for dimensional. So a 3D shape is not a flat shape like a circle or a square. You will see 2D shapes in a 3D shape. For example, in this cylinder, you can see a circle right here. But this is a 3D shape. If it opened, I could fill it with something. So that is what we're going to do. We're going to fill out this anchor chart together. I know that this anchor chart is small, but I will post it up to Seesaw for you guys to use on your homework. So I started here, and I wanted to first go over some vocabulary words. So a vertex is where three faces meet. I think of it as the pointy part of a 3D shape. So for example, this right here is a vertex. So if we look at a cone, let me find my cone. Here's a cone. It looks like an ice cream cone, upside down, or a traffic cone. A cone only has one vertex, just one pointy part. So I put that there. An edge is where two faces meet. So a face is the flat surface of a solid. So on this cone, this is the only face. This isn't flat. So it only has one face. So then an edge is where two faces meet. So a cone doesn't even have two faces. So it can't have any edges. So a cone has 0 edges, 1 vertice, and 1 face. A cylinder, which looks like a soup can, a pop can, has 2 faces. The circles on each side are the faces. This is not flat, so it's not a face. So it has 2 faces, 1, 2, but it doesn't have any pointy parts. So 0 vertices, and then 0 edges because there's no 2 faces close to each other. So the cone and the sphere are kind of the tricky ones when it comes to 3D shapes. So we're going to move on to the pyramid, which looks like the pyramid in Egypt. So let's start with the faces. We're going to work our way backwards on this anchor chart. So faces, 1, 2, 3, 4, 5. So a pyramid has 5 faces. Now vertices are the pointy parts. 1, 2, 3, 4, 5. Also 5 vertices. And then the edges. Let's count the edges. 1, 2, 3, 4, 5, 6, 7, 8 edges. All right, we'll move on to a rectangular prism. A rectangular prism is a rectangle on one side. So if we look at the faces, we have 2 ends, 1, 2, 3, 4, 5, 6 faces. Then we're going to count the vertices, or the pointy parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. And then we got to count the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. That looks like a box of tissues. So now moving on to a cube, which would look like a Rubik's Cube. It's going to be similar to the rectangular prism, except there's no rectangles and they're all squares. So if we count the faces on a cube, 1, 2, 3, 4, 5, 6. It matches the same as a rectangular prism. Let's see if our vertices match up. 1, 2, 3, 4, 5, 6, 7, 8 vertices. So far it matches up. Let's count the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the rectangular prism and the cube have the same number of edges, vertices, and faces. The only difference is the faces in a cube are all square, and in a rectangular prism you have rectangular faces. Now we're going to move on to a sphere, which think of any kind of ball. A baseball, volleyball, basketball, or a globe. Do you see any vertices, any pointy parts? Do you see any flat surfaces? Or edges? I don't either. So a sphere has 0 edges, 0 vertices, 0 faces. Then we look at a triangular prism. So you can see that 2 of the faces in a triangular prism are triangles, which is where it gets its name. So if we start with faces, 1, 2, 3, 4, 5 faces. If we look at vertices, the pointy, 1, 2, 3, 4, 5, 6. 6 vertices. And then faces, edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges. And then we get to the pentagonal prism. So on a face of a pentagonal prism is a pentagon. So we know that a pentagon has 5 sides. So let's start with the faces. 1, 2, 3, 4, 5, 6, 7 faces. The vertices, the pointy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 vertices. And the edges is where things are going to get big. So if we look at one face here, we have 1, 2, 3, 4, 5. Flip it, 6, 7, 8, 9, 10. But then we have to count right here too. 11, 12, 13, 14, 15 edges. That is quite a lot of edges. So I will post this into the Seesaw to help you guys. And then there's some examples here too. So